Hey there, guys. So I wanted to follow up regarding this whole pennies and dollars question that I asked you guys yesterday. So what you needed to do is fill out this table with the amount of money that you would end up making in both situations. So this is the table that Andrew Payne filled out. So Andrew, I hope you were right here. Um, and this does look very good. So the first one, this is not much of a surprise. We knew that we were going to end up with $20 at the end because we were just making $1 a day for 20 days. But this one, the money started out very, very slow, right? 1 cent, 2 cents, 4 cents, 8 cents, 16 cents, 32 cents. It's taking forever, but all of a sudden, somewhere around like here, it starts to get concerning how fast these numbers are growing, right? You kind of start to like wonder, like, wait, did I do something wrong? Because they start growing really, really fast. So fast that by the time you get to day 20, you're at $5,242 on that square of the checkerboard. And then if you add up all of the squares before it, you're now at $10,000, which is crazy. And remember, in our situation, our checkerboard was 64 squares. So we're not even halfway there, and we're already at $10,000 versus this one, which was at 20. So the doubling penny thing actually turns out to be a much better deal. So if you went with that one, awesome. But what we're going to do now is we're actually going to take these numbers and we're going to look at what they look like if we go over to Desmos and plug them in and plot them. So let's head over to Desmos. All right, so one of the cool things about Desmos is that you can enter a table and it will graph that table for you. And I am going to make one minor change to our chart. Instead of saying that day 1 we have a penny, I'm going to change that to be day 0. I'm going to say that today is day 0. So we're going to say that day 0, I have 1 penny, 0.01, 1 cent on the board. On day 1, then we're going to have 2 pennies. On day 2, we're going to have 4 pennies, etc., etc. And as much fun as I'm sure it would be for you guys to sit here and watch me type this entire table in, I think I'm going to jump to one that's already done. All right, so this table I already finished filling out here. The color changed to green. Hopefully you don't mind green. Now, so we can see right away that it's going up very, very slowly. Here's our number 1. In fact, I'll change this to projector mode so it's easier to see. We aren't even anywhere near $1 up until day 6. Day 7 is where we go above $1. So in order to see what this graph looks like better, it's going to help if we zoom out a little bit. And there's where we start to see it going up really, really fast. And we can actually keep zooming out, and it keeps on going up. And remember, we go up to 10,000 almost. So I'm going to change my my axes a little bit. I want my x-axis. I still like it going up not too high because we only go up to 20. So I'll give us a little bit of leeway. I'm going to say I want the highest number to be 30. I want the lowest number to be, we'll do -10. And I'll pick a step of 5. Why not? And then for my y-axis, I want this to go up really high. So we don't need to go too low. I'll go down to -50. But then I want to go up all the way, let's do to 6,000. And then it automatically picked a step of 1,000 for me. That's fine. All right, so now we can see everything that's on our table, on our graph. And there's this really, really shallow line at first. But we can see that it curves and it starts increasing incredibly fast. This is a pattern that actually occurs a lot in real life, and we're going to talk about some of those situations, but there's a word for this kind of a pattern, and it's something called exponential growth. So this is an exponential function. Clearly, it's not a straight line, right? A straight line would look something like this. There's something different about it. This is called an exponential function. So that's what we're going to be talking about today. Now, there's not a lot of stuff that we're going to talk about. We're really only doing kind of a mini unit here, but there is some really important stuff that I need you guys to write down that you're going to want to be able to refer back to. So we're not going to call this a whole chapter. We're just going to make some notes on exponential functions, and there's a few important things that I want you guys to get written down here. So first things first, an exponential function, this looks intimidating, but it's really not. It's just a function of this form, where it goes f of x equals b to the power of x. Okay, and this b is some number. So that number needs to be bigger than 0 in order for it to be growth, and it can't be 1. So you can't put a 1 there. So pause the video here if you need to. You are going to need some more time to write it down, so pause the video. All right, and now I'm going to show you guys an example of one of these. So let's head back over to Desmos. All right, so we're going to come up with another example of something doubling. But what we're going to do instead is we're just going to start with 1. Let's say we start with $1. And then tomorrow, so we're going to say today is day 0, tomorrow is day 1, so tomorrow we'll be at $2. The next day we'll be at $4, then we'll be at $8, then we'll be at $16, then we'll be at $32, then we'll be at $64, etc., etc. Okay, so here's this idea. Since we are doubling every time, we're going to say that we are multiplying by 2. But just like we said in the notes, our x is going to go in the form of an exponent. So we're going to say to the power of x. And as you can see, that red line that it drew from that function I just typed in matches those points exactly. So this function, f of x, equals 2 to the power of x, is another example of an exponential function. We could keep adding points to our table here, so 512, 1024, and they're just going to keep matching up exactly on that line for us. So that's what the basic shape of an exponential function looks like. So add a little section to your notes, and let's draw an example. The basic shape, let's draw some axes here. All right, so like we saw, it always kind of starts out slow, but then all of a sudden it just starts increasing and increasing until it's almost vertical, really. Now, if we go back to our money example, the checkerboard with the pennies on it, let's try to come up with the formula for the equation that represents this set of data. So we know that this is doubling as well, right? But if we start out with f of x equals 2 to the power of x, this is not right? This doesn't match up with our data. This black line is increasing way too fast. But maybe, okay, so instead maybe we could put, we know we started out with a penny, so what if we put 0.1 here? Okay, that doesn't look right at all. That's not even the right shape. So actually having that 2 to the power of x there was absolutely right. But what we need to do here is, since we're starting out with a number other than $1 or 1 whatever, we need to put our starting amount out front. So we're going to, since we started out with 1 penny, we're going to put 0.01 and then times our 2 to the power of x, because it is doubling. And now this matches our data perfectly. So this formula is always going to work for us. If you take whatever your starting amount is and you put it here, and then you put how much it increases by. So maybe it's doubling, maybe it's tripling. So for example, if we had started out, instead of with 1 penny on the board, if we'd started out with 2 pennies, then this black line represents how long it would take that to increase. Or we could have started out with $15 on the board on day 1, and it would have gone up much faster, as you can imagine. All right, so here's that basic formula that we're going to see again and again. F of x equals a times b to the power of x, where a is your initial amount, so in our case it was 1 penny, so 0.01, and b is the rate of growth. So I'm going to add a little note here. So doubling would be times 2, so that would be 2. Tripling is 3, etc. And then x is going to be the amount of time that has passed. So maybe this is in weeks, this might be days, like it was in our case, maybe it's minutes. It's going to depend on what the situation is in your problem. Let's look at an example. So Davion started a worm farm. Who knows why? Maybe he wants to monitor worm relationships. I don't know. Maybe he is really into fishing and doesn't want to keep paying for worms. Either way, he's starting a worm farm, and he starts out with 15 worms, and his worm population triples every week. Okay, they want us to do 2 things. A, they want us to write a function to represent the number of worms on his farm after this many weeks. And B, they want us to figure out how many worms he's going to have after 8 weeks. So go ahead, pause this and write it down if you need to. And let's do A together. So we need to write a function. So it's going to be following this formula right here. F of x equals f of x equals. Okay, we said that we were going to put the initial amount out front. So this time it's not a penny, it's 15 worms. So we're going to do 15 times. Next, we put the rate of growth. So in this case, it's tripling. So we're going to put a 3 here. And then it's going to do that every week. So it's to the power of x, and we know that x is the number of weeks here. So then B asks us how many worms he's going to have after 8 weeks. So what do you think we're going to do with this 8? Well, if x is the number of weeks, we're going to take and we're going to put that 8 where the x is. So we're going to say f of x equals 15 times 3 to the power of 8. And remember, you can use Desmos to help you as an actual calculator. So let's head over to Desmos. And we need to figure out what 15 times 3 to the power of 8 is. And it tells us right here. If you don't know how to get to that exponent, open up this keyboard down here, and your exponent button is this one, a to the power of b. All right, close that. So it's 98,415. All right, so this equals 98,415 worms. Fun stuff. Let's look at another example. It says you find a magic pile of money that doubles every day, and right now there's $26 in it. How many days will it take to exceed, that means go over $1,000? So let's start by making a formula, just like we did before. So we're going to do f of x equals, all right, we need the initial amount here. What are we starting with? $26. Okay, times. Now this is how much it increases by. If it's doubling, we're going to put 2 there. And then it's going to be to the power of x. Now what is x representing in this case? It says it doubles every day. So x is how many days? Okay, it wants us to figure out how many days it's going to take to exceed $1,000. So should I take that $1,000 and put it where the x is? No, because that would be figuring out how much money I have after 1,000 days. That's not what they ask. They said, how many days is it going to take to go over $1,000? Well, let's just kind of start guessing and checking here. What if I did to the power of 1? What if I put a 1 here after 1 day? All right, well, let's go use our calculator. All right, so I'm going to do 26 times. Now, you know what 2 to the power of 1 is. That's just 26 times 2. So this would be tomorrow. In 1 day, I'll be at $52. And you could sit there and double it over and over again. But this will make our lives even faster. Let's try, what about after 4 days? Okay, after 4 days, we're going to be at $416. We need to go over 1,000. So what about 5 days? Almost, 832. 6 days, there we go. We have gone over 1,000. We didn't hit 1,000 exactly, but it said how many days will it take to go over. So day 5 we weren't over yet. Day 6 we were. So it took 6 days to exceed $1,000. All right, so I'm going to say since 26 times 2 to the power of 6 equals $1,664, it will take 6 days.